Hello everyone, let's talk about the origin of quantum mechanics. In this video, I will talk about how quantum mechanics start. Are you ready? Yes, here we go. In the end of 19th century, the knowledge of physics only consists of classical physics, which consists of classical mechanics, electromagnetism, and thermodynamics. However, in the beginning of 20th century, the classical physics are not able to explain some experiment. They do not explain the experiment related to relativistic domain, which is the object that move really fast, approaching the speed of light. Another thing is the microscopic domain, which is the object that is very small, approaching to the microscopic level. So now the quantum mechanics theory begins. In 1900, Max Planck came out with one new idea, which is the quantization of energy. And by using this new idea, he was able to explain the black body radiation. 5 years after, in 1905, Albert Einstein used the idea proposed by Max Planck, which is the quantization of energy. But he do some modification, which is to apply the quantization of energy to light. So he says that light is quantized, and he was able to explain the photoelectric effect. In 1911, Rutherford do the experiment to discover how atom looks like, and he concluded the atom look like this, which has a nucleus at the center, and around the nucleus there is an electron. In 1913, Bohr used the combination of theory or idea proposed by Rutherford, Planck, and Einstein, and he came up with the model of hydrogen atom. In his model, he says that electron can only be found in discrete state of energy. What does it mean? For example, this is the discrete state of energy, which has energy E1, E2, E3, and so on. Electron only can be found in that discrete state of energy. So electron can be found here, here, but not here. We cannot find electron in between of discrete state of energy. Hi electron. In 1923, COMPTON do his famous experiment, which is COMPTON effect, and from this experiment he are able to make the conclusion that light is a particle. And he also able to come up with the equation to calculate the momentum of the particle, since any particle in the world has the momentum. So if he want to claim that light is a particle, so light must have also a momentum, which is hf over c. Also in the same year, 1923, de Broglie says something like this: if light, which is originally a wave, can behave like a particle, why not particle also behave like a wave? So many people think that de Broglie is a dumb because he just said something like this. Okay. However, in 1927, this statement is proved by Davison and Germer by their experiment. In their experiment, it concluded that electron can undergo interference. What does it mean? Electron is a particle. Interference is the wave property. So since electron can undergo interference, we can say that electrons are also a wave because it undergo some wave property. So to summarize all of this, we come to these two guys, Schrödinger and Heisenberg. Both of them actually come up with a very unified theory. It's not too unified, but I want to say it unified because in They both, this guy, combine all the experiment and theory that I already mentioned before, which is Planck, Einstein, and so on. They combine it and do one theory that is called quantum mechanics. The difference between these two, Heisenberg do the quantum mechanics based on metric mechanics formalism, but Schrödinger used the wave mechanic formalism. So my focus is only to the Schrödinger, not to the Heisenberg, because it is not my expertise. Okay. In wave mechanics, the dynamic of microscopic phenomena or microscopic system is described by using the Schrödinger equation, the well-famous Schrödinger equation. And to describe the system, the dynamic of microscopic system, we just need to solve the Schrödinger equation. So this is how, all of this is how the quantum mechanics start. Thank you for watching.